Hello, everybody. Good.
Hi.
Hello. Good
Hello.
morning, good afternoon, good evening, wherever you are. Thank you so much for joining us today. We've got something very exciting lined up.
Totally. Yeah, I'm looking forward to this. Like I wrote in chat just earlier. This is good. I think we are going to have fun today.
Yes. So we have got two wonderful speakers joining us today for Nodes Extended. Super excited. We're going to be joined by Siddharth. We're going to be joined by Elias. And so quick mention about what the format of this is. Actually, I'll hand it over to you, Alex. Do you want to talk a bit about what the format of the session is
exactly.
today?
Yeah. So Nodes 2021 happened in June, right? And we had a great day. We did a pre-stream, if you remember, and we had a super event all day long. And now this today is our extended session. So we had a couple of people that were that we'd like to talk to, but didn't quite make it to be able to include them into the Nodes general agenda. But now we have the additional time and the additional sessions. And today we have, like Lou just said, two great guests, which will share what they did, what they have done with Neo4j and with Graphs, and they will share their stories, will share their experiences with us today, and you will have the chance to obviously ask your questions, to be involved, to take part, and there will be like a short Q&A session towards the end of this. So don't be shy, type in your questions and remarks in chat. Everybody will be able for questions, so you get actually a prime the prime access to the speakers and to us, obviously. So I think it's even better than Nodes.
Exactly. Yes, we are, and we've got the panel conversation as well. So it's going to be great fun. So we're going to have the two speakers. We're going to have the panel conversation afterwards. If you've got questions, chuck them in. I can see some regulars. I can see some new faces in. So do say hello. If we've got a time, we'll do a bit. Maybe we'll do some shout outs at the end. So stick where you're based. We love doing those. It's always fun to see where everybody's tuning in. And without further ado, oh my goodness. Right. So without further ado, we are going to be introducing. Oh, sorry about this.
Did we lose somebody?
No, it's all good. Sorry. I pressed the wrong tab. We're all good. So, sorry about that, everybody. Right, so I'm going to bring this up. Here we go. This is what we wanted. So I'm just going to make us a bit smaller so we can see the screen. So, okay, we have got, like we said, two fantastic speakers joining us today. So we have got Siddharth joining us. So he's a founding research scientist at QUIPU, and he's going to be talking to us about knowledge graphs and NLP. And for those of you who joined us last year, this is very exciting because Siddharth was here last year and he was talking about a project, and we get to get a really exciting update as well. So where the project's gone. So this was looking at connections of Indian politicians and their activities and that kind of thing. So really excited to see what's happening there as well. And then following Siddharth, we've got Elias. So he's the founder of Eureka, and he is going to be talking to us about theta base. So two exciting talks. And without further ado, let's hand over to Siddharth. So just going to get that up and running.
And first of all, I would like to thank Neo4j for providing us the opportunity again to present our work. So we are a semantic AI platform. We bring the convenience and context for your enterprise domain knowledge, as Google does to you for general knowledge. So let us unpack what we mean by that statement. So every enterprise is interested in various information access problems like search, question answering, recommendation systems, conversational AI, metadata management, etc. Gone are the days where different products are needed to address these diverse problems. We believe that QUIPU, by leveraging enterprise knowledge graphs, text mining and NLP, and graph analytics, can be the single platform to address these various problems. In order for machines to perform these tasks and achieve human-like perception, context plays a key role. Let us see that with a canonical example. So when someone presents a statement like this, I saw a jaguar and it is very beautiful, right? Looking at this statement alone, without any further context, identifying the entity of interest is ambiguous. Does it mean a wildcat or a car? So once we provide an extra context, that I have seen it in an Amazon forest and it is very ferocious. Amazon forest is a keyword, ferocious.
Sorry to interrupt you, Siddharth. Just wanted to check. So I don't know if you've got the right window up.
Me, yes. Are you not able to see my screen?
We can see your screen, but we can see the Restream Studio. So I don't know if you intended to have something else showing instead.
Sorry. So I don't understand. So what was the problem?
So can you check what should we be seeing? Should we be seeing some slides?
Yes.
Yeah. So I think you may. I think if you try stop sharing your screen and re-sharing it again, just in case.
Okay. Can you see them now?
No, we're still seeing the Restream Studio.
Okay, they're not able to see the screen. 1 second. Let me just stop and then
Perfect.
Perfect. So I think, can I start it again? Or?
Yeah, yes, please.
Yeah. So, okay. So, yeah, since like I was telling, we would like to bring the convenience and context for your enterprise domain knowledge as Google does it to you for your general knowledge. So let us unpack what we mean by the statement. So every enterprise is interested in various information access problems like search, question answering, recommendation systems, knowledge discovery, conversational AI, metadata management. And gone are those days where different products are needed to address these diverse problems. We believe that QUIPU, by leveraging enterprise knowledge graphs, text mining and NLP, and graph analytics, can be the single platform to address these various problems. So in order for machines to perform these tasks and achieve human-like perception, context plays a key role. Let us see that with an example. So when we see a statement like this, I saw a jaguar and it is very beautiful, right? Without any further context, identifying the entity of interest is ambiguous. So does it mean a wildcat or does it mean the car? So when we add an extra context that I have seen it in an Amazon forest and it is very ferocious, this entity of interest is identified as the cat. Furthermore, we would like it to be linked to the existing concept or the instances in our knowledge base. Similarly, when we provide the context that the car has an amazing performance and its drive is very smooth, now this string jaguar is identified as the entity as a jaguar car. Okay, so in the entire knowledge web, these two strings, jaguar, car, is embedded in a context, as well as the jaguar string, which is a cat, is embedded in a context of the cat. But these two concepts exist differently in the knowledge base. So this is a very famous statement by, oh, 1 second. Yeah, things not strings is a famous statement by Google. And what they mean to communicate with this is that when we are looking for, when we are looking at a collection of words, we would like our systems to identify them as entities rather than just a collection of letters. So what Google does for community knowledge we would like to do, we do it for domain knowledge, be it healthcare, finance, insurance, legal, and pharma, wherein there is a specific jargon and concepts associated with the jargon. So in order to achieve those aforementioned goals of having a single platform to accomplish these various information access problems, we first need to construct an enterprise knowledge graph. So what do we mean by that? Every organization has various data silos wherein the same entity exists in a scattered form. Identifying the canonical entities across various data silos and linking them to abstract concepts codified in the ontology will be the base for our enterprise knowledge graph. And furthermore, the explicit semantics or the rules which are codified in the ontology power us to infer and derive facts using a reasoning engine, thus rendering our knowledge graph semantic. So let us try to understand what we mean by inferencing in plain English. It's a basic inference. For instance, we have an instance data that Socrates is a man. And in the ontology, we have codified that all men are mortal. Now, once these two statements are passed to through a reasoning engine, it infers that Socrates is mortal. As simple as that. So how do we accomplish this in the real life setting? So once we have a knowledge graph, we export it in form of an RDF using the neo-semantics package, a package which supports the RDF serialization in Neo4j. We use this exported RDF data along with our custom developed ontology and a reasoner. And once this is passed to an Apache Jena reasoning package, we infer the data. And furthermore, this inferred data is again pushed back into the knowledge graph using the neo-semantics package. We will quickly run through this because this was the major topic in the last time's nodes presentation. So we would not like to spend more time on this and like to show what we have done in the recent times. So what we mean by that is, if you look at this particular constituency called Andaman and Nicobar Islands, it is a type of a parliamentary constituency. That is where elections are held, and it's an electoral region. Now, once we pass, so it also has other attributes, like we have the demographic data saying that it has a particular population of, let's say, Christians, Muslims and Hindus, and then whether it's an urban, rural, etc. All these are stored as the node attributes, and the inferencing machine would infer that based on these attribute properties, that this is a Christian majority constituency, this is an urban rural constituency, and various other things defined in the ontology. But we know that data is dynamic, and we would like to infer in real time. So any change in the data would fire a trigger, which would again run through an inferencing engine and update it accordingly. So for instance, if we change the data that the majority of the constituency, I mean, that it is a Christian majority constituency to a Muslim majority constituency, it automatically updates that this constituency is a type of a Muslim majority constituency when we change the data. So thus the new information is inferred on the fly. So maybe I can just quickly show you in real time how that happens. Yes. So this is our database. Now we show
oh, sorry. You're good now. Carry on. Sorry.
Can you see the screen now?
Yeah. Yeah, we can see the screen now.
So yeah, this is the Andaman and Nicobar Island, the node in our election database. Now, when we look at it, this is currently the different kinds of concepts it's been associated with. For instance, it's been identified as a Christian majority constituency, and an urban-rural constituency, etc. Now, when we change this statement to, when we are setting it that it's a, when we're setting an attribute, changing it to a Muslim majority constituency, and now when we look at the type it belongs to, it automatically understands that it is a Muslim majority constituency. If you can see this, let me just point it out. So this is a real-time updation of the classes. These entities and instance data belong based on the attributes it has. Not only attributes, we also use inferencing based on relationships as well, which is currently not supported in the new semantics package. That is the reason why we had to migrate to Apache Jana. Okay, so can you? Oh. So can you see the screen? Hello, can you see the presentation?
Yeah, we can see it's all working good here.
Okay, perfect. So once we build this, we would like to perform certain tasks like named entity disambiguation and linking. We would like to perform question and answering system and also product discovery, which are one of these information access problems. So in order to, so NERD, we would like to, use the acronym NERD for this. Identifying entities of interest in unstructured text, disambiguating them, and linking to the ones in the existing domain knowledge graph would be the first step in many information access problems. For instance, search is no longer based on just keywords or document popularity, but on actual content of the question or the query. So in order to build a NERD system, what we do is we need to first modify our knowledge graph, modify in the sense that we project our knowledge graph to entities, concepts, and relations between them. By relations between them, I mean relations between entity to entity, entity and concept to concept. So now, once we have it, we can perform a NERD disambiguation system. So let us just how that works in a domain knowledge. So context-based disambiguation of the mentions and mapping them to the canonical entities existing in a knowledge graph is accomplished by this. For instance, all the words mentioned in the angle brackets are entities of our interest. And if you look here, Jaidev is also a very common name, and many politicians are named as Jaidev. But because of the context it is embedded in, it is identifying to the entity called Gala Jaidev because of the political party he belongs and the embedded context, basically. So, so if we tried the same thing in off-the-shelf NERD systems, this is not very useful for domain-specific text. For instance, it has identified that Galla is an entity and a person, Jaidev is an entity and a person, but it do not identify that it is actually the same person which we are interested in. Whereas here, our system is able to identify it as well as link it to the entity in our database. To go to another example, let's take the case of a healthcare scenario where you have a clinical data record and eventually would like to get some qualified data from it. So the patient's medical record is as a node, which is related to, based on his condition, has related to these nodes, as well as the prescribed treatment for them has been identified. Now, in our database, it is usually a particular entity which exists, and we have to identify that this is the same entity which is being mentioned in the prescribed text. Otherwise, getting a qualified data and using it for internal use would not be very successful. So the takeaway point is, in order to disambiguate and in order to link, the semantic footprint is the core of it. So having the the context, having the entities embedded in this context is what powers the system. Okay. So NERD is very useful for semantic query passing, and it is also a very important component of the question and answering system. So information is everywhere, but it is hard for us to find what we need quickly and to know if we can rely on what we found. So getting consolidated information to answers to questions directly would make our lives easier. So in order to accomplish this, we need to modify the knowledge graph again by refining the graph or adding bridge nodes. So let us go and see what we mean by that. So when we say in the natural language, what is the age of Prime Minister of India? Prime Minister of India is, we are interested in the age of the person called Narendra Modi. But here, we are not directly asking what is the age of Narendra Modi. We are asking a related question, that what is the age of Prime Minister of India? The NERD system identifies that Prime Minister is a concept, India is an entity, which has a bridge node, or we have refined this, which has an instance of Narendra Modi, whose attribute which we pull out and return age as an answer. So, in essence, so there are two ways in which we can implement this question and answering system. On one hand, for today's session, we would only be interested in the on the template-based question and answering system. So the basic pipeline is, once we get a question in a natural language, we use dependency parsing to learn the patterns, that is the grammatical structure and the dependencies of the various components of the sentence, and then map it to a template. Now, once we are able to do that, using distance supervision, we can generate a template bank, which is also a continuous learning paradigm. So if you do not find the existing question in that particular template, it would learn and add a new template. But for today's demo, we would like to just show you without the continuous learning paradigm. But here, another important component is the NERD. Like, it has to identify what are the named entities existing in that natural language question. And more importantly, you should be able to extract the relationships which exist in our domain knowledge graph based on what they're trying to find out. And this is usually accomplished by a lexicon mapping. And finally, what happens after these 4 steps is that we have a template, we have a map from a question to a cipher query. Now, once we get that, we rank the answers, and based on it, we return the most useful one. So at this point, we would like to go into another affiliated product, which is product discovery. As every organization are interested in using recommendation systems, and they basically want to give customers more of what they love. And we do this by using embeddings, knowledge graph embeddings. As a knowledge graph, as many knowledge graphs are, they're heterogeneous, multipartite, multi-relations. So we use embeddings like RGCN, relational graph convolution networks or complex, in order to generate these embeddings. So what does these embeddings do is to essentially give a numerical vector to the entities, to the concepts, as well as the relations. Once we have these numeric vectors, we evaluate a similarity graph based on the entities in order to make it a single partite. And then we can use any of these community detection. We particularly use the Leuven modularity. And then this community's information is again fed back into the domain knowledge. And this can be used to look at similar products, similar politicians, or similar constituencies, etc. So where does all of these three things fit into our system? So we have a knowledge discovery tool called Vachan, wherein it it is built on our electoral knowledge graph, which is of course based on its ontology and this disparate electoral data. That is, we have an electoral data, geographical information data, and demographic data. All of this plus a community knowledge graph, which is usually available in the knowledge bases like Wikidata. So, and this is the input for this entire nerd system. So once a news article comes, it's going to pass through this, and we're going to identify the entities of interest and link various articles as well as entities via this system. So maybe I can now go and show you the platform, which is entirely based on this on your 4J. Yes. So to start off with, let us also look at the, for the sake of, for the interest of time, I'm just going to copy them instead of typing. So we have seen the previous sentence of disambiguation. This is a generic one wherein I saw a jaguar and it is very beautiful, right? So I've seen it in the Amazon forest and it's very fair. That statement has actually yielded that the jaguar is a cat and the Amazon rainforest is another entity of interest. Now, given a, given a different context for the same jaguar, we see that it has been identified as a car. And another concept is the engine has been identified with a diesel engine because that has a higher prior, perhaps. So on the domain knowledge, the example which we shown in the slide, we're just showing it in the demonstration. So, yeah. So here again, Jaydev Galla, the politician who is of interest in this particular thing, has been identified, and the other entities of interest, as well as the concept that political party is a concept. And furthermore, an interesting thing being Guntur, the constituency which he belongs to, is also incidentally the name of a place as well as an Lok Sabha constituency. But based on this context, it has been able to identify that it is actually a Lok Sabha constituency and not the district or the city. Okay. So now what we would like to show you is take a newspaper article and pass it through the system and see how this system processes it and identifies the entities of interest. Sorry for this. I mean, this is an article from the 1st of August. Yes. So we have a scraping system which would take the entire article, get it into a form, and now it has identified the entities of interest. That the Prime Minister is a concept, Mamata Banerjee, and all various other concepts and entities have been identified in this text. Okay, now I think we can look at certain question and answering system. So before we go into it, we are also interested in things where we would like to search two entities together and look at articles where they feature. For instance, when we type Modi went to Varanasi, Modi went to Varanasi, it identifies that Narendra Modi is an entity of interest and Varanasi, and pops up all the articles where these two things feature. Now, if you look at this particular article, if you look at this particular article, what has actually happened is here, the entity called Narendra Modi does not exist, but a concept of the Prime Minister exists. And this is understood that what we have speaking about, we're speaking about Narendra Modi and Varanasi. So this article has popped up. Now let's look at some simple question and answers based on our domain knowledge, which is electoral knowledge. So if I ask a question, what is the age of Narendra Modi? Yes. And it returns a consolidated answer, an information, in fact, as an answer, 70 years and this. And we can also ask a question like winner of, let's say, New Delhi. And we get an answer saying that so-and-so has won in New Delhi in a particular election. So-and-so has won in New Delhi, because we did not specify which election year it was. So it is giving a consolidated answer. Now, we can also ask what is the, what are the assets of Minister of India. So again, here, we are asking a question about Prime Minister of India. It has to understand that we're actually speaking about Narendra Modi. Furthermore, we are interested in assets, which is a concept in the ontology, and it has to look at a bridge node where this information is stored and pull out that particular information. It is given as like, these are the assets of the Prime Minister of India declared in these particular years. And furthermore, we can also ask aggregated queries in natural language. Say, for instance, who is the richest female member of parliament? And it does return. It is understanding that, first of all, member of parliaments are concepts and they have instances, and it has to look at the female candidates out of them, and also has to perform an aggregation over them, that is finding out the max. And so at this point, we would like to also speak a little bit about this knowledge discovery platform before we wrap up the presentation. So, so here, like all the news articles are fed into the system, and they are based on their importance, which is measured based on one, the network importance, as well as a dynamic one, like the trend data, like the trends from Twitter, Google, etc., are consolidated, and these articles have been organized. Now, if we are interested in the articles which feature a particular entity, let's say Narendra Modi, and when you click it, now we get all the articles which feature this entity. And here, if you look at the related entities, this is the recommendation which we have provided based on the embeddings and the community detection. For instance, we understand that he is from the Bharatiya Janata Party. He's contested from these two constituencies. She's a primary opposition leader who was the leader of opposition till long back, and other people who are in a similar category of either the chief ministers of certain regions, because he was an erstwhile chief minister of Gujarat. So all these things are considered, and it is based on the embeddings. If you get good embeddings, we get great recommendations. And furthermore, we have a microsite for each of these entities. So which is provided here, like all the basic data regarding it, which we store in our knowledge graph, is presented in this microsite. Furthermore, we also use data art to present a lot of, let's say, electoral information in a readable and interesting way. Okay, which is still a work in progress. We are yet to completely finish this. And moreover, all these stories are organized according to the timelines. So when we select a particular time period, we can always see what are the most important articles in that particular time period according to our own importance index algorithm, and finally present these things based on the user's interest. So whether he wants to select based on a particular genre or any other filters, they can always, they're free to do. So in essence, this is not just for news articles, but for any knowledge graph. So it would be, you just can plug your knowledge graph into the system and this comes alive. So we provide the microcert for each node, be it a named entity or a concept. And we believe that this form of representation, where each of these articles can be events in any of their domain-specific knowledge graphs. So this form of representation, I think it makes the multi-dimensionality of the graph consumable for a human way. And I think this is an extremely efficient way to navigate through various related articles and nodes based on filtered events. And in our purpose, this would help us to identify related articles as well as help us to see where a particular trail of news leads to. I think I'm going to stop here. Before that, and this is just the honeycomb where we are a middleware. So we, given any data, we build a layer on top of it, and these are the different various tasks which we can accomplish, apart from the ones mentioned in the talk. I would like to stop here, and once again, I would like to thank Neo4j and everyone for listening. We are open for discussions or proofs of concepts on domains related to healthcare, finance, banking, and media and government. Thank you.
Thank you very much. So, very interesting.
Very cool.
So,
very cool.
Yeah, we've got questions coming in. So I'm just going to very quickly just bring up the agenda once more. So we'll be back shortly with you with some questions. And very, very quickly. So we are now going to be bringing on Elias. So he is founder of UES, and he is going to be talking to us what is theta base. So we're just going to bring Elias on now.
Thank you very much, you. As I was asking, how do we deal with questions from the chat here? Can I have someone else read them out from Twitch and answer them, or is it a way to engage with them on video somehow?
Yeah. So we'll do questions at the end. I mean, if you see questions coming up, you're more than welcome to answer them midstream if you're having a go at multitasking. But ideally, if we do them at the end, so we do like a panel conversation. So we'll Alex and I will read the questions out. So cool.
Okay, cool. All right, hello. My name is Elias Moosman, and I'm a longtime graphista, recent co-founder of Responders1 AB in Sweden. We make modern employee engagement platforms redundant. That's one way of thinking about it. But the theta base is one way we do that. We build revolutionary tools to solve modern problems with gamification, multimedia, AI, and human-friendly reporting. Our mission is to help you navigate the future. Today, I'm here to talk about what the theta base does and how we use Neo4j as part of that, and what theta means to us. There's a physics to wisdom. The problem that we're tackling is a hard one, like what you know you can't explain, that sort of problem. Our take on this has to do with how Neo4j helps us create what we call theta. Let's see if I can explain what that means, and I'll keep asking questions to see if I'm being understood. So this is a way to break down the concept of theta, and I'm asking you if you could imagine what this looks like in Neo4j. So to us, theta is the breakdown of thrust, data, and ownership. And this means a little bit different things to us than it might look like at first glance. Thrust is a vector. It's pointing somewhere, so it has a start point, midpoint, and a destination. Yeah, that should be, data is obvious. Everything is data, right? But we're expanding the concept here a bit. And ownership is equality of skin in the game and taking, a strong position. And this creates a sort of overview that we can visualize and look at, which we call theta. And it's really the interaction of how humans interact with the concepts that Neo4j makes relatively easy. Now, I'm aware that this might seem a bit conceptual, and I'm going to do my best to explain how we do this. This is a simple version of the code, the database structure. And I'm sure you might have seen this sort of structure before. Different projects use arrows with midpoints that you can point to, and that's all this is really. It's the same data triple, but you can actually talk about vectors, which you can call these, by pointing at the midpoint. In this example, we have the company respond as 1 down there, and it's doing something to the corp on top there. And that something in the middle, the right it, over there to the right, with the hand on it, has a bunch of attributes that you see on the left. And I'm not going to go into what sort of attributes the attributes have, but you see how this requires a little bit different use case of Neo4j. It's not hard to do. It's not common, but that's what it is. And I think you can guess where this is going. This creates context in a very particular way. So I'm going to speed through this. It's pretty straightforward. If you have a marketing department and you have a company and you create a line between them, we use the metaphor of an arm, and it's grabbing onto something. It has an elbow, and you have another arm grabbing onto the middle of the arm, which also has an elbow. And you can think of this as thrust, as vectors, as forces acting upon other forces. So that's marketing to Acme. Obviously, this goes all the way down the rabbit hole, and if we have a value in the marketing at Acme, which is called Postel's law, it's something that we think is important, that we follow. I'm not going to go into what Postel's law is, but a lot of you, I'm sure, know what Postel's law is. If we do Postel's law well in the marketing department at Acme, it's going to have a certain effect on Acme, which can be modeled. We can measure different ways that interaction goes. And Postel's law can be broken down into 2 different arrows in the same way. Are we generous in what we accept, and are we strict in what we put out? So in this way, we can actually define Acme by extension by how generous are we in what we accept and strict in what we put out. Or instead of saying define, we can affect. This opens up a very interesting picture. I'd be very curious if you what you thought of that. But let me get into the you might have heard a lot of this before. We think of this as a way to open up for what we call interspecies communication. This opens up a sort of way that you can visualize information, you can directly interact with it in a human and machine readable way, and which means that you can have a sort of an enlightened dialogue with lots of different entities. They can be bots, aliens, or vastly different types of people. In this way, you can make explicit those connections, and you can discuss the pros and cons of each. And you can add them up in a particular way. So that's the it. The idea is that this new sort of dialogue can make the pros and cons self-evident, so that they're right there on the page and you can deal with them. This way, we can rapidly get the perspective we need to make wise decisions. We can just think for a moment what this would require in an increasingly uncertain, complex, and fast-moving world, where you just don't have time to crunch all the numbers all the time, and have all those meetings and conversations. This is wisdom is hard to define until someone knows how to scale it. No one knows how to scale it. Or we don't even know what we need to work with it regularly. It's a black box until you have something like this. So you could say that we're creating context. That's one way of putting it. So data versus theta. Data is always driving with the rear view mirror. Theta is what you need to look forward with. By working with intentions, explicitly define where you're going and what things affect that, and working with them as if they were vectors interacting with each other. Goalposts keep moving, and with data, you're typically driving, looking at the back through the backseat rear view mirror. Do we have any questions yet? Oh. So essentially, this is a way to handle a situation where things are just moving too fast. You can't have the kinds of conversations to deal with a complex and increasingly fast-paced situation. And that's why we call this theta. It's a way of connecting the dots, like in a dream, that makes it plain on the page how things are related to each other. We have lots of interface versions to deal with that, or interface concepts, I should say, to deal with that. And but I think you can see how Neo4j and the data structure I just showed you can be used to tackle this problem in a new way. I'm not going to show you the back end of the stuff right now. I can present a few of the concepts for the companies, logos, and so on. And describing a little bit of how it goes together. We call this effect of when you can see the pros and cons easily displayed like that and how they interact for neo-emergent. That's how we manage the interactions and house the data to leverage this in the best possible way. A lot of this data will be gathered from humans, for example, employee engagement surveys, or in different type of active listening projects that we're working with video. And neo-emergent is the concept for how we make those inferences easy and human readable. Human A's are the human-friendly ways of reporting on this, and the human-friendly ways of gathering the data. So it really short-circuits the problem of information gathering, where you're actually influencing and gathering data at the same time in a single step. And it will take me a bit too long for this talk to explain how that happens, but the structure that I just showed you is very important for that. That is a way to manage the complexity that makes it quite manageable for the end user. This is then used firsthand for our app called Respond as One, which if you think of that database structure, it's applied to intentions for your organization and values, really. You can think of them as survey questions if you like as well. And this way, by interrelating them in the sense that in the way that I just showed, you can make very interesting inferences. I keep using that word, but that is really the word. Data is stale. And only when it becomes human understandable and easily connected can you make sense of it and use it properly. And this is what the business app does. Respond as one. And another application of this data model and technique is Exalt, which is a value-creating media platform for active listening that uses this structure to create value in a new way. You can almost think of every second of a video as a survey question, if you like. That's one way to put it. And for Respond as One, we have this idea of culture eats strategy for breakfast. And I'm using these non-technical ways here because they are indicative of how would you even approach a problem like culture with the techniques that exist right now. That's the question. You need a totally new way to manage dialogue and to define information, define categories, interlink data. And that's what our model helps us do, helps our clients do. You can reach me easily on Twitter anytime. Do you have any questions? Oh yes, these companies all use data. That's ties them together.
Cool, thank you very much, Elias. So what we're going to do is we're going to bring everybody back. So bring back Siddharth as well. Fantastic. Oh, I just got to press the view buttons. There we go. Cool. So thank you very much to you both. So we've got some questions coming in. You're also welcome to ask each other questions. So first of all, let's bring up this one. So this is from Ike Mark. And he's asking, so this is to you, Siddharth, is there a way that the inference can be made without having to marshal the data into and back out of the RDF? So what approach did you use around that? And
maybe I did rush to that part because it was discussed last time. Is it okay if I can just explain a bit about how the dynamic data changes? So to his question, let me answer it first, and then I can explain what I wanted to. So yes, certain kinds of inferences are possible using the neo-semantics packages, like if there's a hierarchical data, and inferring that a particular instance of a data belongs to a super category can easily be accomplished using neo-semantics, and that does not require you to export as well as import back into this. But because we are looking at it, much more complicated inferences based on the node properties as well as the relations various nodes have, we had to go outside this and use Apache Jena and a reasoner like Hermit, which is basically inputs an RDF data. And so when I mean by this change of data to infer new information, what happens is, for instance, in this particular census, if this constituency is a Christian majority, and in the next census, if it changes to a Muslim majority constituency, and that data is changed in our database, automatically this is inferred back as a Muslim, as a type of a Muslim majority constituency and not a Christian majority one. Okay, that's what I wanted to say. Did it answer your question?
Cool. Yeah, I'm sure Mark will respond in the chat. So thank you very much. So another question from Mark, which is to you, Elias, which is, what kind of vector operations can you do with the structure setup?
All of them.
Pretty straightforward then. Cool, brilliant. So I guess sort of a couple of questions. I guess to Elias, just if we get a little bit of sort of thinking, you've talked about how you've got this system and the idea of putting together sort of thought and data and ownership and bringing these concepts together. And you talked about some of the applications, but what sort of target application would you see as the first use for this?
We're doing the pilot test for an app that, just like the idea resists definition, it resists definition a little bit, but it's aimed at, I wouldn't say employee engagement, because that's about measuring, and we're about measuring and influencing at the same time. So it becomes a tricky situation where you have intentions for the organization, you have values, and they interact, and some of them are positively correlated, some of them are negatively correlated, some of them this company doesn't want to stand for, some of them are the opposite of what we stand for, and it instantly becomes a huge complex mess if you try to do it regularly, right? So we're using it to untangle the very hard issue of how do we, the catchphrase we use is navigate the future together. That's what's meaningful to us. That's what our mission is. And we use Neo4j for that, clearly. That's
cool. No, thank you. I've got another question for you, Siddharth. That was quite interesting. It's really fascinating looking at the app you put together. And if I understood this correctly, that you're giving a web page address, it's going to go away and effectively do sort of some semantic sort of understanding of the connection to words to be able to figure out what the contexts are, and then you're then asking it questions. Did I understand that correctly?
So this is based on it's based on a Neo4j. So if you are asking questions related to, let's say, electoral information, which is already existing in a Neo4j graph, that it can be it's basically a UI tool in order to write a question in natural language and pull out a consolidated information. On top of it, it's also a tool where we input a lot of news articles. And like I said, we could find the trail of stories. Then we can also look at how similar certain stories are, or what are the related entities, etc. in this context.
Yeah, no, that's. I was sitting there looking at that, and I was thinking, I know you're putting in lots of political data, but I was sitting there thinking you could almost put in financial news stories, and do you start finding the intersection and similarities, and all of a sudden, do you start getting a theme coming out, and does this start to become a potential investment portfolio and that kind of thing? So very cool.
Certainly. I mean, this is just a prototype because we were originally into electoral data, but it's data agnostic. I mean, this tool, and because once you are able to construct a knowledge graph and give a set of rules defined in an ontology, and then everything flows seamlessly from there.
Absolutely. So again, a quick reminder to everybody, if you're on the stream, you're watching, you want some questions, do pop them into the chat. We are keeping an eye on it, so do let us know. So I guess, do you have any questions for each other? Any questions for us? No, okay.
No, that's okay. No worries. I have a quick one, because to Siddharth is this your presentation was so cool, because it showed how powerful this inferred knowledge is by going around and looking into properties or looking into the neighbors of nodes, and then by combining that and driving that information, you get an answer without actually looking at the actually at some of the knowledge you have in your graph. So I think this concept is so powerful. It's really cool. Yeah.
Oh, thank you. And I think we are also really interested to do to develop some proof of concepts in various domains, because really the impact of that could be felt in, let's say, healthcare, finance, and media and governance, which we are already interested in at the moment.
No, absolutely. Cool. Well, brilliant. Thank you very much to the both of you. Thank you, Elias. Thank you, Siddharth. Thank you so much for joining us today. It's been an absolutely fantastic and super interesting session. Thank you to everybody for watching as well and joining in on the stream. And this is Nodes Extended, and we are looking forward to next year for Nodes 2022. So keep an eye out, and we'll let you know when that comes closer to time.
In the meanwhile, stay with us on Twitch. We have a stream later on today with Will on GraphQL, and we'll be back next week with Aura Free.
Excellent, cool. So thank you very much, everybody, and have a wonderful day.
Thank you all. Take care.
Thank you. Bye.
Bye.
Bye, everyone. Thanks.
Thank you very much.